With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's see this question. In this question, it is given that an inorganic iodide A on heating with a solution of KOH, that is the basic solution, gives a gas B and a solution of a compound. The gas B on ignition in air gives a compound C and water. Copper sulfate is finally reduced to the metal on passing B through its solution. You have to find out that what is these statements are correct, which of these statements are correct regarding compound C. So our first aim will be to identify these compounds A, B and C. So let's see what are these compounds. So first of all, what is A? You know very well that an inorganic iodide which reacts in the basic solution to gives a gas can be that inorganic iodide can be phosphonium iodide, because when this iodide reacts in presence of base like KOH, let's see what happens. The reaction is like this: PH4i plus KOH gives you, on heating, PH3 plus H2O plus Ki. So this is the compound which is formed with water, and you can see very well that we have a gas which is evolved, and this is compound B. This B is what? What is B? B is PH3, or you can say it is phosphine gas, right? It is phosphine gas. So PH3 is phosphine gas which is formed when this phosphonium iodide compound A reacts in presence of KOH on heating to form PH3 plus H2O plus Ki. So this is the compound which is formed. It was given in the question, a solution of a compound. Now the gas B on ignition in air gives a compound C. So let's see what is compound C. So when PH3 is ignited in air, so this PH3, when it is ignited in air in presence of oxygen, you have this compound formation, that is P2O5 plus H2O. Now if you balance the equation, then it will be 3H2O, it will be 2PH3, and here it will be 4 oxygen, right? So this is the balanced equation. So here you can see very well that when phosphine, that is the B is that is the gas B, is ignited in air, you have this compound P2O5, which is compound C. So we'll write it is P2O5. Now what was given in the question, that this copper sulfate is finally reduced to the metal on passing B through its solution. So let's say this equation also, that if you pass copper sulfate with phosphine gas, right? If you pass copper sulfate with phosphine gas, the reaction actually occurs in two steps. First of all, you have the formation. This is from inorganic chemistry. So from properties of phosphine and its reactions, you can have Cu3P2 plus 3H2SO4. If you balance the equation completely, then you will have 2PH3 and 3CuSO4, right? So this is the equation. But now what will happen, this Cu3P2 which is formed in the course of the reaction will again react in presence of 5CuSO4 and in presence of water, that is 8H2O, to finally give you 8Cu plus 2H3PO4 plus 5H2SO4. So finally this is the equation. So from here you can see very well that this phosphine gas has reduced, CuSO4 has been reduced to Cu. So this is what it was tell to the it was reduced to metal using the phosphine gas. So hence we are confirmed that B is phosphine gas and C is P2O5, right? Now we have to see the properties of P2O5, because it was asked that compound C, we need to answer on basis of compound C. So first question is, has sp3 hybridization of central atom? So if we discuss the structure of P2O5 in detail, then let's see the structure of P2O5 in very detail. So the structure will be like this. The structure will be, here it will be P, here it is a bridge of oxygen, right? Then you have this double bond O here, then this double bond O to satisfy the valency of phosphorus, and then this double bond O, and here double bond O, right? So this is the entire structure of phosphorus. Now what that is P2O5. Now here you have lone pair of electrons. Now what is important in this structure, that if you see very well, here you have the phosphorus atom, the P atom. P atoms has trigonal planar structure, right? It has trigonal planar structure, and hence its hybridization is, we all know for trigonal planar structure its hybridization is sp2. So it has sp2 hybridization. So this has sp2 hybridization. So what was given in the question? In the question it was given that compound C has sp3 hybridization of central atom. Definitely not. The central atom is phosphorus, and for it has sp2 hybridization, right? Now the next statement is that you need to count the sigma bonds. So if you count the sigma bonds here, so definitely the number of sigma bonds, if you find out the number of sigma bonds in this compound, that will come out to be around 1, 2, 3, 4, 5, 6. So you have 6 sigma bonds, not 16. You don't have not 16, right? You have this much sigma bonds, not 16. So here you can see this statement is also wrong. Now is used as a dehydrating agent. So first of all, what is dehydrating agent? Dehydrating agent is one dehydrating agent that removes water molecule, right? Dehydrating agent is one that removes water molecules, right? So that dehydrates it. So what happens is, because of highly exothermic hydrolysis of P2O5, it acts as a strong dehydrating agent. I will give you the reaction because of the strong highly exothermic hydrolysis of P2O5. Highly exothermic, what do you mean by exothermic? That a high amount of heat is released. So because of which it acts as a dehydrating agent. What is the reaction? I will tell you. P2O5 in presence of water, that is 6H2O, gives us this 4H3PO4. This is very here delta H is highly negative value, so that's why it is a highly exothermic reaction, and because of which this P2O5 acts as a strong dehydrating agent, right? So we will say that the last option, this is the third option, is correct. It is used as a dehydrating agent, but the fourth option, that is all of this, is not correct. So we'll write down our required answer is, the correct answer is option 3 is correct. I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.